Kia ora 11MCA. This video we're going to talk about the quadratic patterns and quadratic sequences. And firstly, I just want to say thank you to this website because I got all these pictures from this website called Project Math Development Team. Okay, so let's have a look at the first pictures here. So we have figure 1, figure 2, and figure 3. Obviously, you can see they have a different number of the squares as well. The figure 1 has 1, and the figure 2 has 4 squares, and then figure 3 has 9 squares. And just by looking at it, probably sometimes you think, oh, is this a linear pattern? So there's an increase by 3, and from 4 to 9 is increased by 5. So this is not the linear sequence. We can straight away tell because they don't have the common difference. Now I just need to think about from another perspective here now. Okay, so this is not linear. What can I do? What kind of relationship can I figure out here? Now the first question is, what is the relationship between the figure number and the height of each figure? So I'm going to label the height of each figure here. So height for this one is 1. Height is 2. And this one height is 3. And I noticed that the figure number 1 is same as the height number 1. And for the second one, figure number 2 is same as height number 2. And for the third one, the figure number 3 is same as height number 3. Now the next question that probably I ask is, what is the relationship between the figure number and the width of each figure? So I'm gonna label the each figure's width. So this is 1. And for the second one, I have 2. And the third one, I have 3. I noticed that even the width number is actually same as the figure number. And now the next question is, so how is the area related to all of these? And what kind of expression that I can use to show the relationship that is between the figure number and the area of these squares? So the area for the first one is 1 times 1, and second one, area figure 2 is 2 times 2, and then third area will be 3 times 3. Now let's say I will keep going and I will have figure n. So the area will be n times by n. So at the end, really depends on what n is, I can figure out the area of that figure. So at the end, I can conclude the area is n squared. And I can call this quadratic pattern because quadratic expressions has the highest power of 2, and which match the definition of the quadratics. So now let's have a look at next picture here. Again, we are going to use the same approach. We are going to ask ourselves, what is the relationship between the figure number and the width, and what is the relationship between the figure number and the height? So I'm going to label all the width and the height first. So this height is 2, 3, and 4. And the width is 2, 3, and 4. So now firstly, how can I get 2 from number 1? So I try, maybe I say this is 1 plus 1, and let's try whether that works for the second figure as well. So 2 plus 1, yes, if I plus 1, I will get the height. And what if the third figure, 3 plus 1 will give me 4, so that's correct. So I can see the pattern of plus 1 to get next figure's height, and which will be the same for the width as well. So now I can say figure number, if say the figure number is n, then the height will be n plus 1, and the width for each pattern will be n plus 1 as well. So therefore, from here, I can find the area of each figure will be n plus 1 times by n plus 1. So it will be n plus 1 squared. So you can leave the expression like this, or if you want to expand it, that's totally fine. That will give us n squared plus 2n plus 1. Again, when you expand it, it's a lot more clear because we have n squared, highest power of 2. This is a quadratic, so therefore we call this one quadratic patterns. Now let's have a look at next figures here. So you notice that these two figures, somehow they look the same, but there's only one difference, which is each figure has one extra box, and that is consistent. It's always one orange extra box, and whose area is 1 times by 1, so the area is 1. So all I know is if the rest will be the same, so I can use the remaining what we got from here, which is n squared, n plus 1 squared. That's what we got from the previous one. And all I need to do is add this one extra bit, which is 1 square unit. So this expression will represent the patterns that we have here. Now, from this, we are going to build on. Now, what if I have another box, like green one here? So now I have one orange box for each pattern. Now I have another box, which is same size, which color in green color, and they are fixed. And everything that's in the purple color, which is same as from the previous question that we have seen here. And we know the area of all that will be n plus 1 squared. And I have one unit squared and another unit square. So total, I have 2 units squared for each pattern that doesn't change. So therefore, I can say the area will be equal to n plus 1 whole thing squared plus 2. Now let's have a look at another question here. So again, start with thinking about, what is the relationship between the picture number 1, 2, 3 and the height and the width? So I'm going to label all the height first. So this is 1, 3, 5. And I'm going to label all the width, so which is 2, 4, and this one will be 6. So let's start from the relationship between the picture number 1 and the height. So 1 and 1 for the first figure is the same, but the second one is picture number is 2 and 3, and then next one is picture number 3, and the height is 5. And then interesting enough, this is 1, 3, 5, which is all the odd numbers. If we look at the width is 2, 4, 6. They are all even numbers. And we know that no matter what number that we have, if it's multiplied by 2, then it's always going to be even number. So for example, the first one, 2 times by the picture number 1 will give me 2. Let's try whether that works for the second one. The picture number, 2 multiplied by 2, that will give us the width of 4. And 2 times by the figure number 3, 2 times 3 will give us 6. So that will give us the width. So now I can see the pattern for the width is always 2n. So 2 times 1, 2 times 2, 2 times 3. Now let's figure out what is the pattern for the height. 1, 3, 5. If you can think in this way as well. The whole thing is increased by 2. So from 1 to 3, increase by 2. From 3 to 5, increase by 2. So this is a linear pattern. So I know this should be 2n. And 2n plus something or take away something will give me each pattern numbers here. So I want to get first one, 1. So what do I need to do? 2n for the first figure will be 2 times by 1. So which is 2. But I need to get 1. So that means I need to take away 1. So that will give me 1. So that will work for this. So let's try for the second one. If I have 2n, 2 times by 2 is 4, but I want 3, so I have to take away 1. Oh, that works, so that will give me 3. So just try the last one. 2 times by the picture number 3, that's 6, and in order to get 5, I need to take away 1. So that means, so I know that for height, the pattern that I got is 2n take away 1. So now I know the width, I know the height, I can figure out the area for each picture. So the area will be 2n times by 2n take away 1. So if I expand it, that will give me 4n squared take away 2n. Again, I got the quadratic expression here. Now, I hope that by now you can get a bit of intuition, a bit of feeling on how to do this now. So let's have a look at these figures here. So I got a bunch of green figures, and you just need to observe it first. So at the end, what we try to figure out is the relationship between the area and the figure number. So that is the equation that we are looking for. So just observe. I noticed that for each individual picture, it has one, use different color here, one box on the top, one box at the bottom. Same here, one box on the top, one box at the bottom, and one box on the top, one box at the bottom. Those are the fixed ones. So I always have 2 unit square of area for each figure. So I know it's something plus 2. So that is fixed. So now all I need to figure out is the middle part, the middle square area. So again, I'm going to start with labeling the width and the height. So for the first one, the width is 3. Second one, width is 4. The third one, width is 5. So let's see what is the relationship between these numbers and the figure number. So from 1, figure number is 1, but I need to get 3. So I'm thinking, can I try 1 plus 2? So that will give me 3. So can I add 2 so that I will get the same number here? So let's have a guess for the figure 2. So I got figure 2, that's 2 plus 2. Does it give me 4? Yes. And the third figure here, using the figure number 3 and a plus 2, does it give me 5? Yes. The answer is yes. So now I have seen the pattern. The pattern will be, let's say figure number is n, and n plus 2 is always the width. Now what we're going to look at is the height. So again, you're going to label the height. Once you make it visual, it's much easier. So label it 1, 2, 3. And I notice that this one is same as figure number 1. 2 is same as figure number 2. 3 is same as figure number 3. So for the height, it's very straightforward. So the pattern is height is equal to n. So n always represents the number of the figure. So now I know the width, I know the height. Obviously, I can find the area. So area is equal to n multiplied by n plus 2. So there'll be n squared plus 2n. Again, we got a quadratic expression here. Or I have to say that now is a quadratic equation, no longer expression, because I actually wrote a equal to n squared plus 2n. I think from now on, you can figure out how to do the remaining questions. In fact, I actually put this worksheet on the Google Classroom. So can you please try the remaining pictures by yourself? You're going to write the equation that shows the relationship between the area and the step number or the figure number or the pattern number. So for this one here, I'm just going to give you a bit of hint. I noticed that these 4 corner boxes doesn't change. It remains the same. Every single picture always have same 4 corners, okay, for a square. And only changes will be the middle square. Now, how are you going to find the equation that shows the relationship between the area and the step number for this question? Please try it by yourself, and if you have any questions, just email me. Thank you.